Hi, welcome to the Solutions Manual. In this video, we will solve the problem 5-42 from RC Hibbeler Engineering Statics 12th edition. According to this problem, we have to determine the support reactions of roller A and the smooth collar B on the rod. The collar is fixed to the rod AB but is allowed to slide along rod CD. So to solve this problem, first of all we have to draw all the support reactions. So at A I have a roller support, which means that I can slide this collar along this plane, but I cannot move this collar perpendicular to it. So I have a reaction generated here. Let's call this AX. Also the movement is also allowed here. So we only have one reaction. At B, I have a smooth collar which can slide along the rod CD, which means the motion is allowed along the rod CD. But I cannot pull this collar perpendicular to the rod CD. Which means that I have a reaction generated here like this, perpendicular to this rod. Let's call this NB. Now I have to resolve this inclined reaction into two components. To resolve NB into two components, we need the angle from the horizontal that the NB is making. So if I draw a horizontal line here, like this, then this angle is 45 because the rod CD is at the inclination of 45 degrees. Now NB is perpendicular to the rod CD, which means this angle must be 45 degrees. Because 45 degrees plus 45 degrees equals to 90 degrees. So now we have found the angle. Now we can easily resolve NB into two components. So if I erase this one, we have this angle equals to 45 degrees. We have one component right here. And one horizontal component. Let's also label them. This one is NB Y and this one is NBX. Since the collar is not the pin connected but the fixed one, which means that movement is also blocked from this collar. I have one more reaction. This is a moment reaction. So let's call this MB, and I am considering its direction as counterclockwise. Now we have drawn all the support reactions. Now we have to use the equations of equilibrium. So our first equation is sum of the forces in x direction should be equals to 0. I am considering right hand side as positive. So we have negative AX, negative NBX. I can write this NBX as NB cos 45 degrees equals to 0. So let's call this equation 1. I have another equation, sum of the forces in y direction equals to 0. I am considering up direction as positive. I have negative NBY, which means NB sine 45 degrees minus 900 equals to 0. From here NB is equals to negative 1272.79 newtons. Now I am getting the negative answer, which means that direction I have assumed earlier are not correct. In fact, NB is in this direction. Now if I put this NB into equation 1, then I will get AX is equals to negative, not negative actually, if I put this right here, then AX is equals to negative NB cos 45 degrees. AX is equals to 900 newtons. So this is the answer for the AX. Now we have to find the moment reaction, this value. For this I have to use the third equation. Sum of the moments about point B equals to 0. I am considering clockwise movement as positive. Now at point B, this NB force is passing through it, so it will not produce any movement about point B because there is no moment arm. Now I have a moment reaction which is MB, and it is in counterclockwise direction, so it is taken as negative MB. Now I have this 900 Newton force which is rotating in clockwise direction, so it is taken as positive. I have 900 into the moment arm from the point B. If I erase it for the time being, then the moment arm is 1 meter, this distance, and this reaction is MB. And I already have a clockwise movement of 600 Newton meters, so it is taken as positive. Now this AX force reaction is rotating the assembly in counterclockwise direction, so it is taken as negative AX. The moment arm is 2 sine 45, this distance, equals to 0. If you are confused that what is point B, then this point is point B. Let me write it here. This is point B. So from here, if I put the value of AX, let's say if I write here, put AX equals to 900 newtons. So from here, MB is equals to 227.2 newtons meter. So this is the answer to this problem. I hope you will find this video helpful. If you do, make sure to subscribe to this channel and also turn on the bell icon for daily updates. And if you have any question about this problem, then you can ask it in the comment section, and I will answer it as soon as possible. Thank you. And I already have uploaded the solutions from the chapter 2, 3, 4 from the same book, so you can also check them out. Thank you.